I'm going to go ahead and do an extrude boss base. I'm going to select that, and right away the extrude boss base dialog box fires up. And I'm just going to I'm using my middle mouse button, by the way, guys, to rotate this. I hold the middle mouse button down and I can rotate it around. Okay. Now you'll notice this little arrow here. You can actually grab that arrow, and a ruler imprint shows up. You can actually drag that, and you can see the feedback there in green. It's giving me the thickness. All right. See that? Or we can come over here and just add in our thickness. I believe our thickness is 5 millimeters. Okay. Now, right now, the graphic screen is showing me that it's going to be going in the positive Z direction. Correct? We want that to go the opposite way. Now, make sure that you do this in the opposite direction. There's some design intent on here. We're going to be using this model later on in an assembly. The first time I modeled this last semester, I did it the wrong way and could not figure out why the hell my model wasn't working. So make sure that you go in the negative direction with the Z. Okay, I'm going to select OK. So now we have a little block. Okay. If I wanted to measure it, I could hit the evaluate, measure, and I could go from this face to that face, and it tells me right away 5 millimeters thick. Hit the escape key, and let's just select the faces first, holding the control key, and then hit measure. Gives me a distance there. Okay. We'll get into it later, but I'll show you really quick. You can also do mass properties. And this is telling me mass properties in grams if this had a density at whatever this is set at. And I'm not sure. This is, you can't read what it's set at from here, but gives you a volume, a surface area. A lot of interesting data. Okay. Now we have our block set up there. Making sure that your Z is pointing, your Z positive is pointing right at you. Okay, we're going to go ahead and select this front face. Now the book shows you how to do this one way. There's multiple ways to do this. You can use the whole wizard, but they want to show you a couple of different ways you can do this. Especially since the whole wizard is a little bit memory hungry. Once you get a large assembly in there and you go back and try to edit a whole wizard, sometimes you'll get messages like out of memory, out of physical memory, or virtual memory. So sometimes you're forced to go ahead and do it the way the book's going to show here. So we'll select this face, select my sketch tab, select sketch, and you can see by the feedback up here in the right corner, I'm in sketch mode. Okay. I'm going to hit F for fit. What's going on here? Oh, automatic updates. Restart later. I'm going to F for fit. I'm going to use my middle mouse button and rotate this just a little bit here. I'm going to hit escape so I can release this surface. Okay. Now, I got to put some holes in this part. So up here in our sketch tools, we have a couple of options. We can do perimeter circle or circle. We're going to go ahead and use circle. And our little toolbox or little tool tip comes up. I'm going to drop the center of the circle, drag it out, select again, and drop it. I'm going to come straight across. You see the feedback it's giving me? This little blue line. It's going to try to throw in a horizontal constraint. So I'm going to select, drag it out, and drop. Okay? And I'm going to hit the escape key to release this tooltip. That's my habit. You can also select the green checkbox, but I'm going to hit escape. Okay. You see the way it didn't add it? It was just showing it. Don't assume that it's actually added in any constraints. Go back and check. So I'm going to go ahead and add that constraint right now. I'm going to select the center circle there. I'm going to control, hold the center circle there, and add in a horizontal. You notice the way horizontals in bold lettering. It's the closest constraint to the way the sketch is laid out at the time. I'm going to select OK. I'm now going to select this circle, the outer diameter, hold the Control key, hold, and select this outer circle. See these new relations that come up? See the way the one's bold, equal? SOLIDWORKS is pretty intuitive, knowing what, or it's trying to guess what you're going to do, and it's a lot of times it's pretty close, pretty right on. So I'm going to select equal, right, and select OK. Now you notice when I drag this circle, the other one follows. If I make this one larger, the other one follows. Okay. So now I'm going to start throwing in some dimensions, some smart dimensions. I'm going to give this a diameter, and we're going to say, I believe it's 4 millimeters. Okay. And I'm going to give it a distance from this edge to the first circle, and we're going to call that 16.5. Okay. And I'm going to go from this bottom edge up, and I'm going to, instead of giving it a dimension, I'm going to go ahead and give it an expression or math expression. 22 divided by 2. Right? And just enter. You can put math expressions in there if you'd like. If you're not sure, you can go as far as 11 times 2 divided by 2, and it'll do it. Okay, so any math expression you need. Now I can tell right now I need to go back and edit my model, but I'm going to go ahead and finish this sketch off. I'm going to go ahead and add a dimension here, and I'm going to call that 39.5. Okay, and I'm going to select OK for now. Now you can see one of these circles is off. Remember I was messing with the size on this this block? I can go about this two ways. I can come over here and hit Features. See this Instant 3D? As long as that's turned on, I can actually grab this edge. Oh, wrong side. Undo that. Grab this edge and actually stretch it out. You see the little ruler that pops up there? Okay, I can go out to the, is it 56? And it's jumping around too much, but you can see you can get pretty close. Or I can just double click that dimension and add it in. Didn't have to go and edit the sketch, didn't have to click anything in my feature tree. As long as this Instant 3D is on, that'll work. Okay? Now I'm going to go back to my holes that I was putting in there. My sketch is still there. It was tied into this side, so stretching this edge didn't hurt it. So I'm going to go ahead and select that sketch and select Extrude Cut. And right away it gives me a visual representation of what's going to be going on here. Drop down condition box right here gives you several selections. You can go blind, through all, up to next. Up to next would work because I'm going to go all the way through. Up to vertex, I could use that and select one of these corners. Up to surface would work as well. Offset from surface, you could get it to work, but there's a lot of going on there. Or I can just select through all. Okay, and it's going to cut all the way through. There you go. There's the first two holes. Okay, now see I'm spinning around here, you know, not sure where I'm at. Keep in mind where that triad is and which way's positive and negative, okay? Like I said, this model is going to tie into an assembly later on, and you want to make sure you model it correct, because when you start following the directions on this this assembly, this bottom-up assembly, I had quite a few students, including myself, who had problems because I extruded the wrong way. Okay, so that's one way of putting a hole in. Now we can put a hole in as well using, under the Feature tab, see Hole Wizard? So I'm going to select the surface first. Now in the book, I don't think they have you select the surface first, but it's the easiest way, most positive way to get a Hole Wizard hole in. So select the start face first, then select Hole Wizard. Okay? Right away, you can see here that there's different hole types. Okay? There's two tabs up here, type and position. We'll go over the position in a minute. But type, you have counter bore, countersink, hole, which is more like a drill. You have straight tapped, tapered tapped, and then user defined or legacy hole. Okay? We're going to go ahead for this exercise and use a countersink. Okay? Once you select the countersink tab, you'll notice that a few selections light up down here. One being, it says standard, and they're talking about the standard, ANSI standard, ISO standard, JIS. JIS is Japanese, KS, DIN, which is German, and also, if you come further down, you'll notice, and some of you mold makers or tool makers may notice, that they also include DME, Haskell metric, PCS, Progressive, and Superior. These are actual vendors. They've gone ahead and supplied the